Thanks for this wonderful introduction. Let me share my screen. So first, I just want to tell you that I would like to have this a bit more interactive, because today we're a rather small group, and I like to reply to all the things you don't understand. So in the following hour, I will explain you a lot about what are these agents and how we can use them for search, how you can create your own agent. And my goal is really to enable every one of you to start building your own AI agent. I want to demystify it. So what I would like you to do is you just, any question comes to your mind, please directly write it into the channel. I first start with introducing Jina AI. A lot of you probably know about us, about what we're doing, but I just quickly give an explanation. So we are the search foundation model. So you know there are a lot of foundation models, and we create the foundation for search. Basically, everything AI related, you need to build your own search engine on your own custom data. And here are just some numbers so that you know roughly what I'm talking about. So we have a lot of tokens processed, not so many employees, but even more open source project than employees. So there's a lot of invention happening recently, founded 2020. We have a lot of products, as you saw before, but I would like to show you the three most important ones. So first, reader. And the reader is used to, it's useful in any kind of search engine. You want to start with getting some data, for instance, crawling some data from the internet. And you usually do this with some LLMs to process this data into your right format. But it turns out that reading just HTML pages is not something what LLMs perform well on. So they perform better on, for instance, Markdown format. And this reader is a tool you can use to create a Markdown format of that website. And then for all the LLM tasks that then perform on this website data, it will be much easier because it has a nice format. And then there are two other things, embeddings and re-rankers. And these you maybe know about embeddings. Fewer people know about re-rankers. This is basically AI for search, not large language models, but models that are trained to perform really good on a search task. I'm here to tell you how you can build your own agentic search flow. And for this, I would like to give you a bit of a summary on where we came from, where the whole research field came from, and the whole industry. So even like a couple of years ago, there was still the paradigm of keyword-based search engines. And then it went to semantic search, and now we enter the age of agentic search. And to show you what these three things mean, I prepared some slides. So here you can see, this is a typical keyword search where you have exact text matching. Maybe you cover some synonyms. So you have a search query, and in your documents you have in the database, you try to find all the documents where there is an exact text overlap, exact word matching. You can use even some synonyms to make this set of possible documents larger. And you also can handle misspelling, but you would never cover all the synonyms or not all the ways the user could type something incorrect. So we have, for instance, this query. So what is the best, or here, best budget smartphones 2025? Which works. So for instance, you have this query, best budget smartphones 2025. And then you have certain documents in your database. And the ones that are retrieved are the ones where one of these words, or as many as possible, match this document. For instance, this document in your database where it says, you care about your budget. Here's a list of best smartphones in 2025. And this document is retrieved from the search engine because the exact words are matching. But then there are some other documents which are also relevant, but they might be not retrieved because maybe you don't cover all the synonyms here. So the second document is, you care about affordable mobile phones. Here's a list of perfect ones for you in this year. And then even though it's semantically equivalent, it's the same, but it will not be discovered by the user because it's a keyword-based search. And now we move to the next paradigm, because people invented then semantic search. And they found out that if you train these embedding models, and you can get even matches, even when they don't have the same word matching, but even if it's semantically equivalent. So it would also match things like purchase with buy. It's possible now. But these semantic search engines, they also have a bit of other problems. So they suffer, for instance, from recognizing IDs. So this ID here looks, so it's matching here, okay? But in this document, it will also provide this document as an answer because, yeah, semantically matching for the embedding model, this ID looks almost the same. It's just an ID. So semantically, it's a list of random numbers, basically. So we'll put these both very close to each other and we'll retrieve this document. It cannot differentiate so much about these things we care a lot about. So then the solution was, what about hybrid search? We combine the best of both worlds. And we can use the semantic search to get documents that are semantically equivalent, but still have identifiers defined, where some words that really have to match the query, the document from the query. So, and this also works great, but of course, we still see limitations. And one of the limitations is that shows this example. So for instance, you have the query comparison of Google Cloud and AWS pricing. Here, this document will be retrieved. It will be something like, here's an overview of all GCP and AWS offerings and costs. So it covers this, it's matching the query. But this document will just not exist. So there will be not one single document that contains all the information. So reality is different. In reality, all the information is scattered around the internet. Some information will be on the AWS side. Some information will be on the Google Cloud side. Even on that page, it will be in different sub-pages. And it's just not one query that can be answered by a single pass-through the search engine. Instead, the information is on multiple documents. So how to even determine what is the best document from my database for that query if it doesn't exist, if like all documents are the best one, because they all contain all this necessary information to give an answer to my query. AI agents. So now we are entering agentic search. What you can do now is you give this task to a search agent, and the agent will use whatever search system it has and try to do multiple iterations of search and proceed until it finds all the relevant information on different sources to then provide a final answer. And then it finds, for instance, even this piece of information. At AWS, we offer NVIDIA H100 for that price. So, and there's no way, whereas classic search engine, even semantic search, to match this document, because there's very little overlap between these queries. So I hope you make you very curious on how these AI agents actually work. And here I give you an illustration that is very common in this space. So when you see a talk, then often you see this kind of illustration where we have this friendly looking robot in the middle, and then there is a query coming from the user. In this case, user is interested in the cheapest GPU with 80 gigabytes VRAM. That's it. User want to have the cheapest one. And now the agent is taking over the task. Instead of directly putting this in the search engine, the agent is getting this. And the agent, it has some tools. For instance, there's access to some search engines. Also at Jina, we also provide a search engine, search.Jina AI, and will be also listed here. But it has also others like Brave, Perplexity, and so on. And now the agent, it takes this very specific query, but put this directly in search engines. What it does instead is it creates a list of a short list, or a bit longer maybe, of search queries where it knows these search queries perform good on these search engines. And then, for instance, for this query, it creates NVIDIA A100, 80 gigabyte, and then pricing. But it also creates some other search queries. And then it waits for the results we get from the search engines. And then it decides, maybe it already knows the answers. Maybe this was sufficient information. It already found something that is so cheap, it thinks that it won't find something cheaper. And it returns the final response. But maybe it finds something very expensive. It thinks it's expensive. And it goes into another iteration, thinking again about new search terms. It can feed into these engines and then get proper search results. And it goes until at some point it thinks it can output a final response. So what I would like you to do now is to think about what is this magical component in the middle, this friendly looking robot. Because we have a lot of slides in presentations where these robots show up. And then as long as you look at this slide, everything makes sense. But then when you get asked, what is this actually? How would you even implement it? Then it's sometimes feels like a bit difficult to answer. So I would like everyone to write in the chat, what do you think is this? Can already say it's 3 components. Can you list at least 1, 2, or maybe already 3 of the components that are necessary to build this? I can already tell you it's relatively easy to build. Cool, we get something in the chat. So I see LLM. That's correct. I see RAG. Maybe we have to talk about this. Something else. So you just need the LLM. Tools. Okay, the tools I have here illustrated at the side, so they don't count. Okay, training is needed for LLM. That is also true. What else do we have? Tools. Embeddings. Yeah, embeddings would be needed in the search engine. Processor. 100%. Of course, yeah. Okay, maybe it's 4. Maybe it's actually even much more things. Of course, you need the processor to process the LLM. API, a lot of correct things. Probably I should extend the list to many more things. Okay, thanks for giving all these answers. And what I would like to focus on is now 3 things. So a prompt, an LLM, and a loop. So loop, piece of code. And it's really just these 3 things when you develop something and you have already your processor, your machine. What you need to create such thing I illustrated here. So not much, and therefore it's not surprising that many people build these open source frameworks now. So what are the prompts? So that is a prompt. That I claim is everything you need for what I showed you before. And don't even try to understand the complete thing and read through everything in detail. I would like to quickly explain you roughly what it does. It first defines here is a user request. I'm looking for a GPU, 8 gigabytes, and so on. So this is a user request it gives you. And then it gives a list of question-answer pairs. And remember, in the first iteration, there is no question-answer pairs. So in the first iteration, it's empty. But later, when it goes multiple iterations, it collects all the question-answer pairs that were given already. And then I tell it can decide between 2 things. Either it outputs this JSON format with the final answer, or it outputs a list of queries. That's everything we need for it. We'll look back to the slide from before. So either going this way, final response, or this way, generating all the queries. So that's really it. That's the prompt. That's everything you need for the prompt writing. And then this is the code. Also, don't try to fully understand it, but just realize that the code is very small. It's not much needed. And also realize that there is a while true loop. So this is the iterative process. It goes again and again. And there's one possible way of returning. It's if the final answer turns out to be, or if the answer turns out to be the final answer, then it interrupts this loop. And otherwise, it's iterating over, running the prompt. So here's I mocked this function called LLM. And then getting the response, see if it's final answer. If not, then again, do a search. And then append to the question answer pairs and run again and again and again. So this is very, very simple. But in its most simplistic form, right? You can build very complex agentic search system with a lot of code. And also at Jina, we built our own versions that is very capable and has really thousands of lines of code, right? Don't understand me the wrong way, but just to get started and to solve your specific problem at your company quite sufficiently with search agents, this might be enough. this piece of code. So one thing you might have seen is that with each iteration, we append something to the question-answer pairs. Here's a while true loop. So this might run for a very long time. This actually, like when we look here, you have multiple search engines. So maybe for each of the terms you create here, you put this into multiple search engines and get a lot of question and answer pairs. So this grows. And then we put this into our prompt here. So this will be a very, very long list. And maybe you face a context problem. Maybe it grows so much that either the context of the language model cannot handle it anymore, or you don't want to pay for such long context. So there are ways you can overcome this problem. And this is summarization. So what you could also do is user request comes in, then there is a prompt. You split up the prompt. So it's not a single prompt anymore. There are multiple ones. And you have just one prompt that decides, should I give a final answer or should I make a search? If it does a search, then you have a different prompt that generates the search queries and is very specialized to that one, to this one specific task. And then when you get all the queries and retrieve the answer documents, then we face this problem of long context. So every time we retrieve a document, we summarize it and have very concise information. Maybe even have another prompt that removes redundancy with things that already got answered and so on, compressing everything. And then this makes the context usage here much smaller. It will be much easier to handle than this prompt. So whenever something is not working, you split it up, divide and conquer, divide the problem into sub-problems and solve them independently. Yeah, and this is just a summarization prompt. So probably nothing special here to mention. But what is worth mentioning is our own node deep research tool we created at Jina AI. And this is completely open source. You can also use our API, but you can also download this. You can also look into how we tackle things, more advanced things like the budget usage. We've seen as a while true loop. For programmers, it's never good to see a while true loop because there might be no end condition. So this problem is tackled here, for instance. Then certain memories, AI agents can have memory assigned and so on. This is more sophisticated projects. There are many more of such open source projects because, as you can see, it's quite easy to build, to get started with at least. So this one is like takes a lot of work to bring it to a certain level then, but that's why a lot of people jumped into this field. So if later we have some time, I can also tell you about how you can host such things. And for now, I would like to give you some use cases. So in many companies, you might have the challenge coming up that you have to find out what is our main competitor within the company. And then you do your research, you find out, what products do I have? What products does the competitor have? And we found these ones as well. And okay, we update the list, we update the Excel sheet and so on. So I think everyone tackled this problem from time to time. And that's why it's good with Agentic Search. We have a semi-automized solution for this. So what the agent can actually do is it can find previous analysis within your company. So most likely your company, if it's a bit exists for a bit longer, then it already has some internal documents. So search engine that works on these internal documents, then the AI agent can use that search engine and retrieve all the previous analysis that were made on this topic. Might become useful, right? When you want to get an updated comparative analysis. Then the agent can search online or also on internal data what the product offering is of your own company. And then, for instance, where are the markets, and finding other companies that offer the same products in the same market. So in each stage of this, so when we go back to this graphic, then the input query would be, give me a comparative analysis of, for instance, my company, Jina AI. And then the agent won't find a document online giving all these informations, right? Because who would put this online? Maybe some people do, or maybe they don't have incomplete data. But instead it can create all these queries like I listed, they were in green, now shown, and can then go in iterations and get closer to the final answer, develop a partial solution towards the final answer. So it generates for each of these points, it generates queries and retrieves documents, and then is able to provide a final answer, almost, because there are certain things that the search agent won't be able to do, or we don't want it to do, because it's maybe it's not so trustful at the moment, especially if we have the first version and we don't know if it works really good. Then certain things we want to prevent it to do. For instance, it should not be allowed to call a tool that is sending email asking someone if they have certain ideas or insights into this comparative analysis. Maybe we wanted to write such email, but you probably don't want it to automatically send something, because sometimes things go wrong, and we're still at the start of this AI era, and we want to put some guardrails. So these things, or talking to colleague, maybe the colleague has some nice ideas regarding comparative analysis. This is something the agent just cannot do or should not do. Looking into physical documents, yeah, of course. So I was also asked for this presentation to give a bit of outlook on where the field is currently going, and what will happen in the close future. And there will be always these things that it can do, these things that it cannot do or we don't want it to do. And then there is like this simultaneous research, collaborative type of research. Humans do something, and at the same time, the AI search agent is also gathering information, and this is collaborative systems that come up at the moment. And before I continue to the next examples, I was talking for a long time, and I don't want to leave everyone hanging. And usually when I give presentations, I get immediately feedback when someone doesn't understand something or thinks it's too boring, let's continue, or something like this. So I would like to use to ask a moderator if there's already some interesting questions coming up related to all the things I said so far that we can tackle right now. Dear moderator, probably you are muted because I don't hear anything. Okay, I will be my own moderator. No worries. Let's get this done. So I go through some of the questions. Yeah. How does the LLM decide which is the final answer? Oh, yeah, that's a good one. How does it decide? How will we find out? Yeah, basically, how will we find out how a black box does make a decision? So this is also a question we should ask ourselves. And there's a lot of research. At the end, it is a black box. It's like this stochastic system, next token prediction, and who knows what it outputs, right? It's just very likely that in questions or situations where it gathered enough data and all the information is present, that it will then generate the final answer. So this is likely, but it's not guaranteed. It's never guaranteed. But it becomes already so likely that it's almost guaranteed for certain cases, for certain scenarios. So we cannot really find out at the moment how are these models even able to generate the final answer, but they do. So then next one. Yeah, I can make the slides available. Sure. If agents can cite specific sources in their output, that would be a good way to ensure the agent is providing accurate answers. Yeah, correct. So more advanced agents, when they respond, they generate their final response, then also in this final response, they have citations that make the user then able to go back to very specific source in the on the website, maybe even the line, the exact citation where it got this information from. And then you can build up trust that you can trace back what was a decision made on from this agent. How does your agent know it's final and there's no more info? So I assume, like, how does it know the final answer? We covered this already. Would this rely on the search engine, LLM, and training, or private or open source LLM? You can with this framework I gave you, with this lines of code, I made it agnostic to all the LLM provider. So it can be open source. It can be also behind an API. There's no function calling or fancy APIs needed that only specific providers have. You can use this with any of these LLM providers. Can this be defined as a classic collective intelligence model? Does it work, or can it be adapted as an evolutionary genetic algorithm? Thanks. I would be also interested in that question. And the answer for that question. Well, I don't have an answer, sorry. But that's interesting. Verifying the results somehow. Yeah, there are benchmarks. So you have set of questions and answers, pairs, and then you give the model a question, and then it generates, after some turns, it generates an answer. And then you can have in your data set, your evaluation data set, you have the ground truth, and you can check if this is matching. And it will not be perfect match. So you usually use also an LLM as a judge to then check if these two are matching. And yeah, it can be a bit more complicated because if it's a public data set, then the search agent will also have access to this public data set and could cheat. And this happened to us in the past. So we published our own evaluation data set, and then it turned out our agent was suddenly performing really good. Like we made some small changes and performed really good, and find the answers to all of these questions. But the problem there was it cheated. It found its own evaluation data set online on GitHub and then cheated on the answers. And there are many approaches that can cover this. But yeah, it's a bit too much for this session, I think. API page we can cover also the API. Search and input processor, LLM. Okay, these were the things from before. And then, yeah, how does agent know its final answer? Can you please make slides available? Okay, this was before. Please check question and answer. I do right now. Thank you. What are the major historical challenges with this model? So with this very simplistic thing, so the question is, what is basically the challenge to everything I told you already? So one of the challenges I said was this context size. This is growing over time. We have a lot of other problems. So what also can happen is that it diverges in certain directions. So I remember we had one query, giving this comparative analysis for Jina AI, and then it turned out to give a final answer about chocolate. It was totally unrelated. It had nothing to do with the original question. It was because in each of these iterations, and it had 50 iterations or even more, in each of this iteration, it diverged a bit from the original question to do its own kind of research thing. And then you get a final answer about chocolate. So this is very challenging. Then also how to handle budget. So we have at the moment, we have a budget cap where we say for each search query, you can spend a certain amount of budget, like really financial budget. And if that is spent, then give a final answer. Don't continue in this loop. And then you have memory things, or the challenges, so that the thing can remember actually something from previous interactions and so on, or cross users. So from there are many more challenges. So next question. Asked to do ChatGPT 4.0 and Llama 4 already do all of this? Yeah, exactly. So there are even more of these research tools. So what I tell you here is a paradigm, so that you don't think like, okay, they have this magic thing like no one knows about. No, they have this kind of system they all implement. There's all these deep research type of applications. They're implemented in this or similar way, but more sophisticated, of course. So do ChatGPT for all Llama already do this? Yeah, okay, same question, same answer. Best way to learn how to do agentic search. Actually, the best way to learn is probably not enough to listen to this talk, but based on what I told you, try to implement it on your own. Because I now gave you all these three ingredients, this algorithm, you have an LLM, and the prompt. And with this, you could write your own Python script that's doing your own agentic search. And then once you have this, then you can see, okay, what search engine do I integrate? How do I give a benefit to a company I'm working at with this? So, but yeah, only way is to actually do something, but I think it's easy to get started. So is HITL, what is HITL? Human in the loop, required at any stage to refine the model output? No, not at any stage. So there's some stages where just a tool call of the agent is just simple search query. So search engine, not many things can go wrong. So you don't need a human in the loop, only for more critical things like sending email, deleting a user, whatever. Do you use any similarity metric to generate these documents? To generate these documents, this maybe you could clarify. We'll first go with the next question. Does the summarization of different search queries happen in LLM? Will it not increase token size? Yes. Summarization happens inside LLM. That is true. So you put so your in first step there will be the search terms created, right? And then these search terms feed into the search engine, and now you get maybe a complete website or a list of complete websites as response. And then the question is, yeah, but how much do I really save because when I now summarize it? Because even for summarization, I need LLM to tell the LLM, here is the website search results. Please compress it, make it a bit smaller. But you only have to do this once, right? Compared to not doing this and putting this all into this, maintain this question answer document pair list, and then have the complete documents there. This will add additional context in each iteration and will grow much more. I hope this answers the question. Otherwise, we have to discuss more in future. Yeah, don't miss out. Join our Discord. I can totally agree. So you can see in the chat there is the link to Discord channel. You can join and join the community. Oh, link to Discord expired. Don't use that link. Wait for the next one. And it's already there. So I think you said LLM could cheat based on human relevance judgment data set. Are you referring to data leakage during training or something else? Please, can you explain? This is 5 minutes ago. I put this maybe back for a moment because I already explained this. And if it needs further explanation, if I missed something, please then write again. So, I mean, is similarity metric used to receive documents? Yes. Okay. Now I get your point. Yeah. So I didn't talk about the search engine, right? But so who knows who all these search engine providers do this? They certainly use keyword search and also use some similarity search metrics to come up with the top search results. But you can also, when you use your own search engine, so here Jina, we built our own search engine, search.jina AI. Yeah, we also use these metrics. You can build your own engine and use whatever metric you want to. So that's then the freedom there. Cool. So still 15 minutes left, so we can continue to to another case. I just want to give you more inspiration because something I was giving similar presentation to this, so and then people afterwards even didn't really know, like, okay, what can I use it for? But I claim everyone can use agentic search, and it will be beneficial for everyone, almost every company that has a bit of data laying around. So maybe this question came up in the past within your company. So the question is, last year we had this technical problem. How did we solve it? And for instance, how did we fix our slow SQL query? And then you're there like, yeah, I remember there was this issue, but how did we fix it? And then you go again, you go from first principles, try to think about, and then will take you maybe a couple of hours to fix this issue. But it should be not so difficult because it was solved in the past. So why is it difficult to solve it again? And what you can do is you have already your own search agent within your company, and you make it solve this task for you. And what it probably will do is finding previous incident analysis and trying to find in there, is there something that matches what this problem description is very similar to? And then also find internal documentation, maybe it's internal wiki or something, logs, error reports. It can look into a lot of data within the company. And then maybe there's even like search relevant archived internal communication. Maybe there's an archived Slack channel. And the Slack channel was for triaging this issue, and then the agent can discover this channel and read all the communication and then give a final answer. But maybe all these things were not written down, and maybe the agent cannot find everything. So then only talking to this one colleague that is now on vacation can solve the issue efficiently. It depends, and human work is always required, right? Or at least very, very beneficial to solve these kind of challenges. And then another issue, for instance, what are the top complaints about our customers? And then again, certain things agent can do, reading relevant emails, find relevant product reviews, and so on. It cannot do an interview with customers directly, or not in a good way, not really experience how the customer is using a product or something. This qualitative analysis, this it cannot do, but give you a lot of insights in this. So and many more, but we skip for now, many more use cases. And they say you always should have a take-home message. Most important key takeaway of this. And this is that this friendly-looking robot that also looks a bit magical is actually demystified by now. It's just this. It's a prompt, it's an LLM, and it's a loop. Thanks a lot for your time. And I'm happy to answer more questions.
I think we're going to wait for a few minutes for questions. If you guys have any questions, feel free to ask right now, or we can conclude the session. Oh, we do have a question, Florian. Are you thinking of MCP in addition to tools? In the chat box, if you can see.
Yeah. So MCP, if I'm not mistaken, is this adapter. It's a format or a convention that was created to make tool calls, make a common interface between all large language models and tools. And yeah, so communication that could also be could also work in MCP. So this is just the benefit that you have a standard, and then whatever you implement, you can pull in more tools because they also have the same standard. Right, but when you only focus on search, and it's like most important for you for search to have the search engine working, then you can just pimp basically a bit of your existing code that is directly calling search engine, and instead just have the agent in front, piece of code and agent looping over search engine, making multiple calls. So it's not really necessary to get started, but you can.
That's great. Do we have any other questions? Guys, we still have time. Feel free to ask any questions if you have.
Okay, people find helpful. That's good.
Yeah, in the meantime, it was truly one of the most interactive sessions we have had. So kudos to you, Florian. It was a great session and a very insightful one indeed. And you had a great presentation lined up. Moreover, until we have any other questions coming up, I'll be sharing my screen and show you guys if like our community events page. Feel free to, we have a couple of events lined up. Hope you guys are seeing my screen right now. And we have a major community series coming up with Arise AI as well. We have 3 parts lined up. As you can see, what is an AI agent? Feel free to RSVP for this session on our events page, or I'll also share your link among the network for others to know about this event as well. Moreover, we'd like to introduce to our major community server, Discord. On Discord, feel free to get all the recordings of the sessions in the past, and of course for this session will be uploaded here as well, so that this is something that is great. You can always refer to this anytime at any point of the day. Moreover, our upcoming events are also lined up here as well, including our info session, so don't forget to join the server, as well as you will have the access to our exclusive resources on our learners lounge. So this is something great. You can get all the PDFs that we share and exclusive content that our alumni share as well, and the Q&A chat as well. So feel free to join the community server and get the wholesome experience with us. And in the meantime, Florian, it was truly a great session indeed. And we do, I think we don't have any, yeah, we do have a question, Florian, if you can answer quickly. The budget for tokens for LLM decided for a project, if it's not sure how much search queries will be needed. So that would be great if you can answer that.
So what I was talking about before is this question referred to is we in the loop, the while true loop, it burns a lot of tokens, right? And it runs at some point so long maybe that my credit card gets blocked because it consumes all my money. So this is also an exit condition, but we don't want to have this. So we apply a budget on each query. And a budget is really like what you think it would be. It's a money cap. It's saying, for instance, at maximum 1 cent can be burned for a query. And then we count all the tokens that were processed and then calculate the price that was paid for running each of these prompts. And then at some point it aggregates to hit the cap, the limit, and then we force it to give a final answer. Cool. And thanks a lot for having me. I'm really happy. And I also like that a lot of people liked it. So it's good. Cool.
It was totally